Okay, this is the same assembly line balancing handout example, but this time we're gonna do the boxes way, not the tables way, and we're gonna use rules, not trial and error. And by rules, we're gonna use the following rules. One is a primary rule. PR, primary rule, which means the rule that you will use first. We're going to use the largest task time. So you're going to select tasks to assign to workstation based on their task time. So if one takes 4 minutes, the other takes 3 minutes, you're going to select the one to go for to assign the one that has 4 minutes. Secondary rule, SR, if there is a tie with the primary rule, you're going to use the secondary rule to break the tie, and that is largest number of followers. So that's a rule that we are going to have to calculate. So for each task, we're going to have to come here. T time is given to us. We're going to have to make another column here and call it followers, F. And we're going to calculate for each task the number of followers it has. So for A, for example, how many followers does A have? And that's all the followers that come after A. So 1, 2, 3, 4, 5, 6. A has 6 followers. B, 1, 2, 3, 4. Notice C is not a follower of B. So we don't count it. A is not a follower of B. So the followers of B are D, E, F, and G. How about C? There's only one follower for C, and that's G. Okay, so now what about D? 2 followers for D. E, 1 follower. F, 1 follower, and G doesn't have any followers. So these are the rules we're gonna use. Now, we said before, with trial and error, we may come up with different answers. With rules, unless you have a tie on the primary rule and a tie on the secondary rule that you can't break and you have to break randomly, you may end up with different answers. Otherwise, the answers should be the same. So we're going to use the same example, but we are going to give the cycle time this time, and we're going to use a cycle time of 6 minutes. So given a cycle time of 6 minutes, do ALB for this problem. And this is not uncommon, that you may be given a problem and you are asked to do calculate the cycle time, the minimum number of theoretical minimum number of workstations, but then you are asked to do ALB given a certain cycle time, so that not all your answers are wrong, even if you calculated the cycle time wrong. So we're going to use the cycle time of 6 minutes and do ALB using these rules. So let's get started. So now we care about time and predecessors. By time I mean the cycle time, not to exceed that in each workstation, each box. We care about predecessors. We can't put a task in a box if its predecessors are not completed. And we care about the rules. So we have a new area here that we have to focus on that we didn't when we were looking at trial and error. So we're going to do this using the boxes idea. So we start with our first box, and this time we have 6 minutes. So what tasks can we start with first? So we start with A because A doesn't have any predecessors. A takes 4 minutes. So if we're done with A and we have 6 minutes, we have 2 minutes left. Once I do A, we can do B or C, correct? Because both of them will fit. We have 2 minutes left, B or C. On time, both of them will fit. One is 2, the other is 1. My primary rule says pick the largest task time. So B takes 2 minutes, C takes 1 minute. Which one should I pick? B, of course, because B is 2 minutes. So I don't have a choice. It's not I can do whatever I want, like trial and error. I have to pick B because B is 2 minutes and C is 1 minute, and the primary rule tells me to pick the one with the largest task time. So that leaves me with no idle time at this workstation. But we don't have to track the idle time because we can calculate it at the end, unless you want to confirm your answer. So, open the next workstation. Now that I did A and B, I can go with C or D. C or D or E, it looks like. C or D or E. Correct? C or D or E are eligible to go in the second workstation. So let's see which one has the largest work time. It looks like E takes largest task time is E, 5 minutes. So we have to put E first. Once I put E, I can still do only C or D because I cannot do G yet. F is not done, C is not done. Now, in terms of time, there is a tie. C, D take 1 minute. CD takes 1 minute. And so I have to go to the secondary rule. The secondary rule, let's look at the number of followers. Each of them takes 1 minute. How about the followers? C takes 1 follower, D takes 2 followers. So then, which has more number of followers? D. So I have to take D. So now, if I take D, then again, there is no leftover minutes. I used up all my minutes, so I close it, no idle time. I open the third workstation. I have brand new 6 minutes. I can put C or F, which has the primary rule, the largest task time. That would be F. So I put F first. That's 3 minutes. The only one I can put in is C, because G has C, E, F as predecessor, so I have to put C. 3 plus 1 is 4, and unfortunately I can't fit G because that will exceed the cycle time, so I have to close it, and I open the last workstation, and I put G in it, and I will have 2 minutes of idle time here too, and I'm done. So this is how you do it with rules. Now the metrics, you can calculate them exactly the same way. You end up with N, actual number of workstations, of 4 with this new cycle time. So now what you can do is calculate the efficiency. So that would be the sum of the TI again over N multiplied by cycle time. So that would be 20 over 4 multiplied by 4 by 6 multiplied by 100. So that would be 20 over 24. So that's 83% approximately. And then we have a balanced delay or total percent idle time of 100 minus 83, so that's approximately 17%. and then total idle time equal to n times ct minus the sum of ti. So that would be equal to 4 times 6 minus 20. 24 minus 20 is 4 minutes, which is the 2 minutes here and the 2 minutes there. So that's how you do it with rules. Now the only rules we are gonna cover in this chapter are the largest task time, the largest number of followers. There is another rule which is called the greatest positional weight, which is explained in your book, and that is the time of the task plus the time of all following tasks. So, for example, what would be GPW for task A? Well, that would be 4 plus all the following tasks. Well, that would be the sum of TI, right? So that would be 20. What would be GPW for task B? Well, that would be 2 plus 1 plus 5 plus 3 plus 4. So it will be 8 plus 7, 15. And so on. We'll take a few more examples. GPW of C, 1 plus 4, 5. GPW of F, for example, that will be 3 plus 4, 7, and so on. So then you use it like you use the rule of the most number of followers. And if you're picking between two tasks, you'll pick the one with the largest GPW. That's it.